What is forensic science? Almost every night on TV, we can watch criminals commit a crime, leave behind obvious evidence. CSI teams collect the evidence and solve the crime. The criminal goes to jail. If you don't watch CSI, how about reading a book or watching the news? Forensics is very popular in the media. There are so many different books, movies, TV shows, even on news footage. Every day we see something about criminal investigation. On TV, we get to interrogate suspects, thus we kick down doors, make judgments about guilt or innocence, operate independently of other investigators. For instance, we get to go to crime scenes without permission. We usually have multiple expertise. And we get to act like detectives. We ask why. Why would someone do this or someone not do that? We get to rely on hunches. And we get DNA results in a day. In reality, we never interrogate suspects. We often go to crime scenes long after the crime. We never make judgments about guilt or innocence. This can compromise the impartiality of the scientist and the scientific method. In reality, we work as part of an investigative team and usually in a subordinate role. Police are ultimately in charge. Usually do not have multiple expertise, deal only with observable and quantifiable phenomena to reach theories and conclusions, meaning that we deal with things that we can see and measure to reach theories and conclusions. We don't just make it up. And we don't get DNA results in a day. So what is forensic science? Well, it's the application of science to the law. The study of forensic science cannot be completed in one semester, but we can start the process by learning about this fascinating field by looking at one major area called criminalistics. So what is criminalistics? Well, it's the application of physical, chemical, and biological methods of analysis of physical evidence taken from criminal investigations that is Locardian in nature. And that's an interesting word. We will revisit that and learn a little bit about it. Criminalists use the scientific method to solve their problems. First, they make observations, then they form hypotheses, then they have testing, and there's a negative feedback loop there because sometimes the testing will lead to other testing, and then eventually there is a theory that develops. Criminalistics is the only science that deals with individualization, meaning that specific evidence is very individualized. Now here's that Locard person and the Locard exchange principle. Now I will mess this up a little bit because my French isn't that good, but Edmond Locard in 1920 published Les Contes criminels et méthodes scientifiques in Lyon, France. And basically what he said is that every time two objects come into contact, a transfer of physical evidence occurs and therefore creates a record of the action. And this is the guiding principle of criminalistics. And if you question that, go and pet your dog or your cat or walk outside and walk back inside and you'll notice there's dirt on your shoes or there's dog hair or cat hair, or even walk from one room to the next and you'll see that you carry things with you. Fibers from the carpet, you leave behind dust, hair, that sort of thing. So every time two things come in contact with each other, there's a transfer of physical evidence. The Locard exchange principle deals with identification and individualization of the material that can link suspects with victims and link people with crime scenes and objects. So we have the suspect, the object, the crime scene, the victim, and the physical evidence in the center. And you'll notice they are all linked together. The more associations there are, it helps lead to identifying suspects, providing investigative leads, disproving or supporting accounts of the crime, and crime scene reconstruction. Criminalistics is a three-tier process. There's the front end, which is the hypotheses formation at the crime scene. That is unique. It will be different for every crime scene. Then there is the middle, which is the applied, and that's testing in the laboratory or field, and that's physical, chemical, biological methods, and we test our hypothesis. And then the back end, which is unique also for every crime, is proving or disproving hypotheses and giving testimony. This chart will help you take a look at and put in your mind how criminalistic works, or how forensic investigation works. First, there's recognition, then there's documentation, then there's collection and preservation of the evidence, and identification of the evidence, because we don't always know what it is. We compare it to known samples. There's individualization of each piece of evidence. Then there's evaluation and interpretation of that evidence, reconstruction of the crime scene and the crime and how it happened, and then reporting and presentation of that evidence. And yes, you may have to do expert testimony as a criminalist, because someone has to go to court and make those presentations during a trial. So once we have formed a hypothesis for the crime, we test the evidence. This is the area most of us are familiar with from television, and that's conducting tests in the laboratory. This point is also when we either prove or disprove the hypothesis. Forensic scientists usually report the results to other law enforcement officials and really don't need to do anything else. But there are times when forensic scientists are required to provide expert testimony. So it's very important that while you are in this class, and if you choose this as a career, that you know all the history and background for chemical tests, biological tests, any kind of physical evidence testing. So throughout this class, we will cover the history, the science behind it, and then the application to forensic science and to crime solving. Enjoy!